An Evaluation of Aircrew Fatigue, Solutions for Ineffective Regulation by James Earl Jones for the College of Aeronautics, Embry-Riddle Aeronautical University, ASCI491, Operational Applications in Aeronautics, with Professor Kenneth Cherkis, May 16, 2021. Managing aircrew fatigue has been a problem in the aviation industry for many years, and different approaches have been used to reduce accidents related to aircrew fatigue. However, it is often hard to identify until individuals show outward signs of fatigue. According to the FAA, fatigue primarily becomes known only after an event manifests itself into errors by the aircrew. Attempting to mitigate accidents caused by aircrew fatigue, the FAA has passed various regulations, but incidents related to aircrew fatigue continue to occur. The FAA's position is that what causes fatigue is not as important as the effects of fatigue on an individual's ability to complete a task. This position should be examined and other methods evaluated to find a solution for the accidents that continue to occur due to fatigue. Today, there are hundreds of airliners that are in use that are capable of carrying over 400 passengers, with the largest capable of seating 853 passengers. It is easy to see that the importance of addressing aircrew fatigue cannot be overstated, as accidents today can result in a catastrophic loss of life. Using FAA regulations and peer-reviewed articles, this research will examine measures to reduce aircrew fatigue and compare them to FAA regulations that have not effectively addressed the issue. The research found that the FAA regulates fatigue centered on aircrew flight time, duty periods, and rest periods. For flights operating under the Code of Federal Regulations, Parts 121 and 135, there are more than 25 regulations that apply differently to aircrew dependent on various criteria. The problems with these rules is that they cannot mandate the aircrew actually rest, plus they are applied differently to aircrew depending on the purpose of their flight. To solve this problem, the FAA added 10 regulations to Part 121 carriers, including the requirement that aircrew affirm that they are fit for duty. The biggest issue with this requirement is that it is subjective and appears to do little to prevent accidents and is more of a means of assigning blame. Additionally, after the terrorist attacks of 9/11, the FAA required that aircraft have a door installed between the cockpit and passenger compartments. This causes some aircrew to remain in the cockpit for longer periods throughout the flight. Provisions were made to allow crew members to leave the cockpit as long as there was no potential for passengers to enter the cockpit when the door is open. However, those who stayed in the cockpit longer tended to experience higher fatigue levels brought on by boredom. This research studied many peer-reviewed articles written on the effects of stress on fatigue levels. Most found that ergonomic risk factors such as poor placement of controls and inadequate viewing distances to instruments contributed to stress. That, combined with the added stress on aircrews when working in a complex aviation environment, resulted in increased fatigue levels. Thus, adjusting cockpit designs and control layouts greatly reduced stress levels in aircrew and showed a corresponding reduction in fatigue-related errors. Aircrew come in various physical sizes but are generally the same in terms of anatomy. Using adjustable seats and controls which allow aircrew to comfortably reach and manipulate controls greatly reduces fatigue. Because of the sheer number of cockpit controls, touchscreens can incorporate input and output devices into smaller areas, and repetitive eye movements can be reduced to lessen eye strain and its fatigue. Additionally, touchscreens contain support tools which have been shown to reduce errors in the event of a safety alert, reducing aircrew stress by helping to solve alerts quickly and improve situational awareness. Results of this research reveal that fatigue is not easy to gauge because its effects vary from person to person based on different variables in their lives. If it were easy to gauge, FAA regulations and ergonomic controls to reduce aircrew fatigue would have stopped fatigue-related accidents. They have not. One reason for that is that the controls that are in place can only subjectively determine fatigue levels. Thus, outward signs of fatigue may not be present even in highly fatigued individuals. Those individuals can continue to make mistakes, possibly without even knowing for themselves that they're fatigued. Getting closer to eliminating all fatigue-related accidents will require something that augments FAA regulations and ergonomic controls. With their main drawback being that they are subjective, filling the gap may be possible using a test that can objectively measure fatigue levels. Here, Tests to find chemical markers in blood and saliva samples may help fill the gap. The testing is in its early phases, but further development could allow the samples obtained from aircrew to help identify their fatigue level, whether or not they feel fatigued. Still, fatigue affects each person differently. Thus, many considerations must be worked out for chemical tests to be practical, as it is not necessarily the method being used as much as how the method is used. Based on the researchers' findings, regulatory and non-regulatory methods used to reduce aircrew fatigue have worked to a point, but further work needs to be done to reduce the number of accidents that still occur. To this end, some of the methods being used can be modified or removed to enhance their effectiveness, and new methods should be explored to gauge their effectiveness in bridging the shortfalls of the other methods. Here, the FAA should standardize aircrew duty time requirements by ensuring that Part 91, Part 121, and Part 135 requirements are the same, regardless of the purpose of the flight. Standardization will enhance meaningful enforcement and prevent airlines from using Part 91 to bypass aircrew rest time requirements. Stress has also been shown to cause fatigue, and ergonomics have been proven to reduce stress. Because of this, airlines should implement ergonomics training for their personnel and work with manufacturers to implement changes to the aircraft design, including retrofitting older aircraft with touchscreen instruments whenever practicable. Airlines should also provide rest areas at airports where crew can sleep undisturbed between flights. These areas should be available to aircrew 24 hours before the initial flight to allow them a significant opportunity to rest away from activities outside of flying. Studies have shown that outside distractions, especially around the home, prevent people from getting quality rest. The FAA and airlines should also work to further research into blood and saliva biomarker testing to develop objective tests capable of detecting fatigue levels in aircrew. Afterward, objective testing for fatigue should be incorporated into regulations as part of each airline's fatigue management program. Additionally, regulations that rely on subjective testing should be reviewed and removed if they have not proven effective. Although these recommendations can help to reduce fatigue-related accidents even further, the end goal is to completely eliminate accidents caused by fatigue. We're getting there, but more work needs to be done to reach that goal. Thus, the researcher recommends that others interested in this area of study conduct additional research to fill in the gaps and deficiencies with current efforts. Doing so can help make the airways safer and move aviation closer to becoming an accident-free industry.